So for this unit, we've worked on a lot of skills relating to radicals. We know how to simplify rational square roots. We know how to use a calculator and to estimate without a calculator irrational square roots. We can distinguish between rational, irrational, and imaginary, place square roots on a number line using our estimation skills, and determine what two integers and irrational radicals between. And some of us have done the extension where we are simplifying square roots. Now we're going to apply those skills to solve equations with x squared. So you may or may not have these exact notes in your notebook, so you can either follow along or you can just watch the video to learn the concept. So the concept is solving quadratic equations in the form ax squared plus c equals 0. Quadratic equations have an x squared as their highest exponent in them, and what this is saying is that we're dealing with equations like this: 3x squared plus 5 equals 0. We are not dealing with equations like 3x squared plus 2x plus 5 equals 0. This extra term with the x would get us stuck right now. We would not be able to use a square root to solve it, and you will learn how to solve equations like that using factoring or the quadratic formula or completing the square, all in Algebra 2 next year. So when you see a problem like this, x squared equals 100, that is saying what number, when squared, equals 100. And we know that both 10 and negative 10, when squared, equal 100. So when you see an equation with an x squared, you are looking for two solutions, and if you do not include both of them, then you do not have the correct answer. So you can read the statement in words where it says, since it's 10 and negative 10, we have to provide both values in our answer. We can say 10 or negative 10, or we can write plus minus 10, which we say as plus minus 10, which means that both the positive and negative values will make this equation true. So before we get into some examples, let's remind ourselves about inverse operations. So we use inverse operations to solve these equations just like normal, but instead of isolating x, we're going to isolate x squared, and then we'll have an extra step here where we have to take the square root of both sides. So the inverse operations, or inverse operations in general, are operations that undo or reverse each other. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. And squaring and square rooting are inverse operations, but I'm going to have you put the plus minus here to remind you that you're actually taking a positive and negative square root to undo squaring something. So as a quick refresh of how we would use inverse operations to solve for x here, I'm going to highlight the x that we're solving for in each of these equations. I have x plus 4 equals 18, or what plus 4 equals 18. And to solve this, I could subtract from both sides. So 14 plus 4 equals 18. That's my solution. I could plug 14 back into my equation, and I would see that I get something that's true. Similarly, when I have 3x equals 108, 3 times what is 108, I could divide by 3 to solve this, and I would get 36. Or 36 times 3 equals 108. Now I see a two-step equation. What number doubled minus 10 equals 70? Let's add the 10 to both sides. That leaves us with 2x equals 80. And then we'll divide by 2 on both sides to get x equals 40. If I plug that back in here, 2 times 40 is 80, minus 10 is 70. And now is the new part. What number squared equals 16? A lot of times our instinct is to just say 4, but we also know that negative 4 makes that true. So I would isolate x squared, which is already isolated here, and then I'm going to take the square root on both sides with this plus minus sign. So my answer here is x equals the positive and negative square root of 16. That means x equals either 4 or negative 4. And we often see it written like this: x equals positive and negative 4. You might even see it written in brackets like this: 4, comma, negative 4. It's not parentheses, it's brackets there. And if I were to plug that number in and check it, 4 squared equals 16, and negative 4 squared equals 16. So now let's do a few more examples, and then I'll point out some key ideas. So we're just going to skip all the way down to the examples themselves. So the first one says x squared equals 25. So again, I know that there are two answers that make this true. So I'm going to take the positive and negative square root of both sides, and I get x equals positive and negative square root of 25. So x is either the positive square root of 25 or the negative square root of 25. I again could write it like this, but I find that a lot of students then assume that it's always the same number plus and minus, which it will not be eventually. And if I wanted to check this, I would check 5 squared equals 25, which it does, and negative 5 squared equals 25, which it does. Anytime you leave your answer exact, it will check. If you got an irrational radical and then estimated it, it would not check exactly. So the next problem says 3x squared equals 108. This looks very familiar to where we did 3x equals 108 up here. So we're going to use the same inverse operation here. We're going to divide both sides by 3 to get x squared equals 36. And now we just have one more step than we had before. We're going to be taking the positive and negative square root of both sides. And again, the reason for that is to cancel out this squared, right? So before, when we divide by 3, we're canceling out our coefficient of 3, and now we want to cancel out the squared. So you may even want to draw that in to remind you of what you're doing. So I have x equals the positive and negative square root of 36. I mean, what I'm essentially saying here is that we have the square root of 36, and we also have the negative square root of 36. Notice that that negative is on the outside. That is why we are able to do it. If the negative was on the inside, we would, of course, get a non-real or imaginary solution. So I get x equals 6 or negative 6. And if you would like to write it as x equals positive or negative 6, you can with that plus minus sign there. I could check it. I would square 6 and get 36, and then times 3 is 108. And same thing if I plugged in the negative. The last problem here, so again, we first need to isolate this x squared. This problem is very parallel to the one that we did here, where we had 2x minus 10 equals 70. Well, now we have 2x squared minus 10 equals 70. So we'll have the same inverse operations. Add 10 to both sides. That gives us 2x squared equals 80. We're still trying to isolate x squared here. Divide by 2 on both sides to cancel out our coefficient of 2. We get x squared equals 40. Now is our new step. Before we had a 40, but now we actually need to undo the square on this. So we'll take the square root of both sides. We get x equals positive and negative square root of 40. Now 40, our radicand, is not a perfect square here. And so we will need to look to see if the directions say anything about how to either simplify or leave this exact or estimate. And there's a little note about this down here. So it may say to leave our answer exact. This would be an exact answer. When I plug that in to check it, it would work. It may say to simplify it, which was an extension. And so some of you may know how to do this, to write this as 2 root 10, because the square root of 40, if I did this over to the side, was the square root of 4 times the square root of 10. And the square root of 4 is 2. We cannot simplify the square root of 10 at all. So you might leave it like that. Or in the directions, it might say to estimate. And so if it said to estimate, we would need to figure out the square root of 40 is between the square root of 36 and the square root of 49. We'd estimate how far along it is. And so we'd say x is approximately positive and negative 6.3. And so it really just depends what it's asking for. So these are both exact. This one is also simplified. And the second one here is, or the third one here, sorry, is estimated. So we would always look to see what the instructions say if we get an irrational radical for our solution. Although I wrote these with the plus minus, I just want to point out, let's say we were taking this first one here. I could have also written this as x equals square root of 40 or negative square root of 40 to remind myself that there are two solutions there. When I say exact, what I mean is that if I were to substitute my solution in to check it, it would check in the original equation. So, for example, here was the original equation, 2x squared, so I'll plug in square root of 40, minus 10 equals 70. Well, the square root of 10 squared is just 40. So 2 times 40 minus 10 equals 70. That is 80 minus 10 equals 70, and that comes out true. So I could check it, just like we have always liked checking our solutions. Even if I had put a negative in here, that would end up being positive after I squared it, so it wouldn't change any of my calculations there. Similarly, if I put in a 2 root 10, I'd have 2 times 2 root 10 squared minus 10 equals 70. Well, we need to square the whole inside, so I'd be squaring the 2 and the root 10, because I'd have 2 root 10 times 2 root 10. So 2 times 2 is 4, and root 10 times root 10 is 10, which would end up giving me a 40. So after this step, I would just be right back here. Versus if I had put in 6.3 and squared it, 6.3 squared is not 40. It is 39.69. So you can see that although it is a good estimate and we get something close, we wouldn't actually be equal on both sides. We would just be close on both sides. So for those of you that want to know what we're actually looking for here, we want to know when x squared, and if I were to graph y equals x squared, this would be a parabola shape, when that function equals 9. So if I were to look at the graph, this is the graph of y equals x squared. You may have seen it earlier this year, and we see that it equals 9 when x is negative 3 and when x is 3. We can picture this as xy, so we're basically saying when is y equal to 9, because when does x squared equal 9? So we see that when x is negative 3 and when x is 3. So because we have something squared, we have a parabola shape, and so we will end up having the same y value for two different x values here. That's not the case if we had something like x cubed. X cubed is more of an S shape. And when we go to solve, I'll come back to that. If we were solving, let's say we were solving x cubed equals negative 27, there's only one value that makes this true. The only value that makes this true is negative 3. Negative 3 times negative 3 times negative 3 is negative 27. Versus in the next problem, x cubed equals 27, the only value that makes that true is a positive 3. And so if our index is odd, when we take a cube root or a fifth root, etc. of both sides, we do not use the plus minus because there's only one value that makes that true. Versus when we square a negative or square a positive, we end up getting the same solution. One final thing I want to point out is just all the different ways you may see your answers. So this is the way that I've been writing a lot, although I think I did not include the second x equals, which is actually good if you do include it. So we would get x equals 3 or x equals negative 3. You also might see it pretty commonly like this, x equals positive or negative 3, x equals plus minus 3 here. Sometimes we forget then that there are two solutions. That's why it might be helpful for you to write both of them. You might see them just with a comma between them, and more mathematically accurate, you might see them in a list in these brackets. These are not parentheses. Parentheses would indicate it as an ordered pair, but we could have more things here inside. Since there are two solutions, we only see two items in our list.